Welcome to English for Professional Mechanical Engineers. My name is Jin Tu. I'm glad to have this opportunity to speak to you today about Computer-Aided Engineering, CAE. In this lesson, we are going to introduce the sixth section of CAE, Heat Transfer Analysis. Let's start. Heat transfer is a principle of thermal engineering that concerns the generation, use, conversion, and the exchange of thermal energy and heat between physical systems. Heat transfer is classified into various mechanisms, such as thermal conduction, thermal convection, thermal radiation, and the transfer of energy by phase changes. Engineers also consider the mass transfer of different chemical species, either cold or hot, to achieve heat transfer. While this mechanism has distinct characteristics, they often occur simultaneously in the same system. The fundamental modes of heat transfer are: first, elevation, the transport mechanism of a fluid from one location to another, and it depends on motion or momentum of that fluid. Second, conduction or diffusion, the transfer of energy between objects that are in physical contact. Third, convection, the transfer of energy between an object and its environment due to fluid motion. The fourth, radiation, the transfer of energy by emit electromagnetic radiation. Regarding elevation, by transferring matter, energy, including thermal energy, is moved by physical transfer of hot or cold object from one place to another. This can be as simple as placing hot water in a bottle and heating a bed, or the movement of iceberg in change ocean current. Heat conduction, also called diffusion, is the direct microscopic exchange of kinetic energy of particles through the boundary between two systems. When an object is at a different temperature from one another or is in surroundings, heat flows so that the body and the surrounding reach the same temperature, at which point they are in thermal equilibrium. Such a spontaneous heat transfer always occurs from a region of high temperature to another region of low temperature, as described by the second law of thermodynamics. Conduction is the most significant means of heat transfer within solid or between solid objects in thermal contact. Fluids, especially gases, are less conductive. Fourier's law of thermal conduction states that local heat flux density is equal to the product of the thermal conductivity and the negative temperature gradient. The heat flux density is the amount of energy that flows through a unit area per unit time. Q is equal to minus K multiplied temperature gradient, where Q is the local heat flux density, K is the thermal conductivity of matter, gradient T is the temperature gradient. Steady-state conduction is a form of conduction that occurs when the temperature differences drive the conduction is constant, so that after an equilibrium time, the spatial distribution of temperature in the conducting object do not change any further. In steady-state conduction, the amount of heat enter a section is equal to amount of heat come out. Transient conduction happens when the temperature within an object changes as a function of time. Analysis of transient system is more complex and often call for the application of approximation theorems or numerical analysis by computer. Heat convection occurs when bulk flow of a fluid, gas, or liquid carries heat along with the flow of matter in the fluid. All convective processes also move heat partially by diffusion as well. The flow of fluid may sometimes be forced by buoyancy forces in gravitational fields. When thermal energy expands the fluid, thus influencing its own transfer. The process is often called natural convection. Another form of convection is forced convection. In this case, the fluid is forced to flow by use of a pump, fan, or other mechanism means. The basic relationship for heat transfer by convection is Q equal to H times Ts minus T infinity, where Q is the heat flux density, H is the convective heat transfer coefficient, Ts is the object's surface temperature, and the T infinity is the fluid temperature. This expression is known as Newton's law of cooling. Note that convective heat transfer coefficient is dependent upon the physical property of the fluid and the physical situation. Thermal radiation occurs through a vacuum or any transparent medium, solid or fluid. It is the transfer of energy by means of photons in electromagnetic waves governing by the same laws. The Stefan-Boltzmann equation, which describes the rate of transfer of radiation energy, is as follows for an object and its surroundings. Q is equal to epsilon times sigma times the force power of Ts subtract from the force power of T surrounding, where Q is the heat flux, epsilon is the emissivity, unity for a black body, sigma is the Stefan-Boltzmann constant, and the T is the absolute temperature. Radiation is physically only important for very hot objects or for objects with a large temperature difference. The term phase transition or phase change is the most commonly used to describe the transition between solid, liquid, and a gaseous state of matter, and in rare cases, plasma. A phase of thermodynamic system and the state of matter has a uniform physical property. This diagram shows the nomenclature for different phase transitions. Phase transition or phase change takes place in a thermodynamic system from one phase or state of matter to another one by heat transfer. Phase change examples are the melting of ice or the boiling of water. Phase transition involves the four fundamental states of matter. First, solid, deposition, freezing, and the solid-to-solid transformation. Second, gas, boiling, evaporation, recombination, deionization, and the sublimation. Third, liquid, condensation, and melting and fusion. And the last one, plasma, ionization. Next, we will illustrate some CAE application of heat transfer analysis. Several small ceramic plates are cooled by an aluminum plate, in which cold water is conducted through the circular channels. The steady-state temperature distribution of ceramic plate are obtained by an CAE simulation. Another example, a lower plate is heated by an upper plate by means of thermal radiation. The steady-state temperature distribution of two plates are obtained by a CAE simulation. Do all of them make sense? Finally, we prepare some questions for you. Question 1. The direct microscope exchange of kinetic energy of particles through the boundary between two systems that are physical in contact is called as A. Advection, B. Conduction, C. Convection, D. Radiation. Yes, the answer is B. Conduction. Did you get it? Question 2. The flow of fluid is forced by buoyancy forces when the thermal energy expands the fluid, thus influencing its own transfer. The process is often called A. Conduction, B. Forced convection, C. Natural convection, D. Radiation. Okay, the answer is C. Natural convection. Question 3. Which mode of heat transfer is the transfer of energy by means of photon in electromagnetic wave? A. Advection, B. Conduction, C. Convection, D. Radiation. Yes, the answer is D. Radiation. So this is the end of this session, heat transfer analysis. I will see you in next video. Goodbye.